Alright, so this is another exciting statistics video. This is your first exam video. Um, for the first exam, we're going to take everything that we've been doing all semester and then applying it to this data set. We've looked at this data set before, except this data set's mixed up a little bit. Just to warn you, there's a fly buzzing around in here, so if I spasmodically start flailing around or my eye closes, it's because it's landed in my eyeball again. Alright. So what the purpose of this data set is to try and determine who are males, who are females, and who are alien imposters. Okay, there's a really simple way to do this. We're going to look for people who don't fit in. We can identify two parameters based on certain characteristics. The easiest way to do that is to use error bars and z-scores. Okay, so I'm just going to do this very quickly. First thing you want to do is start looking at z-scores. If you notice in the column that says sex, it's coded as 12 and 66. So by sort ascending, there's a bunch of 12s and a bunch of 66s. You have to determine who those people are, and then try to figure out who are the imposters. Okay, so as we're looking at as we go through the data, we have the first thing we always do when we look at the data is make histograms. Just look at the data, see if there's anything weird. So we're going to make histograms. We're going to start with the femur by normal curve. .477 with a standard deviation of 51 seems relatively normal. Okay, so let's do the same thing again. We can go to histogram, and now we're going to look at foot size. Okay, something's different. I see a definite bimodal distribution. Make sure we make a note of that. Okay, and this next one is, oh, this looks a lot like the data we saw with the reaction time data. Something's wrong. So we're going to have to investigate this. That one score doesn't seem to fit the parameters of everybody else. That one score doesn't seem to fit the parameters of everybody else. So we'll go look at that in a minute. Let's just make the last one. Well, two more, sorry. Relatively normal distributed. There's some very short-armed people there, but this is so exciting. Wow, very normally distributed. Okay, so except it's very flat across the top. It seems to be plateaukurtic, which means there might be more than one mode here. Anyway, just a hint. So I'm going to go back up and look at this head. Okay, so let's go and descriptive, descriptive. I'm going to make some z-scores just for everybody because I can. Okay, so I calculate my mean standard deviations mode, and let's go look at the data. Okay, so when I look at the data, let's look at that head first. That's the one that really sort descending exactly like we did before. And whoa, that's definitely not normal. 6 standard deviations away from the mean. So we'll have to fix that. So we go look at the raw data, and it says 1200. The rest of the scores are close to 500, 600. So 1200 is definitely not right. So I'm going to code that a 0. Now before I do anything else, I have to go to variable view and make sure missing equals 0. Okay, so for head, missing equals 0, because we know someone can't have a 0 diameter head, so it's a missing data point. So by coding it 0, let me go delete this column again. Let's make that column again. See if it lines up better. It's made the head column again. So now I've got my head and 2 standard deviations away from the mean. Okay, that's big, but not outside of possible, because there's only one score out there. And then there's only one score there, and then the rest of them fit within the normal parameters. In fact, everybody fits within the normal parameters, except, let's go to the bottom, and oh no. Whoa, something's wrong here too, because look at this. -6. So someone has a 9 centimeter These are millimeters, so a 90 millimeter head. That's about a little bit bigger than a grapefruit. That can't be right either. So I'm going to code that as a 0 as well. Just delete that again, and then calculate it one more time. And let's see if that normalized the distribution. Let's make the graph, histogram. Well, there's still someone who has a very small head in there, but that's not too far outside the normal range. That this distribution looks much better than that distribution did. So far, so good. So if we want to try to identify parameters, we have to look at error. So let's make some error bars. Graph. Now we're going to be, everything's measured in the same units in this. It's all millimeters, but it's hard to make millimeters on the same graph because a millimeter on your leg is different than a millimeter in your height. So we're going to use an error bar, and we're going to make error bars of the z-scores. We're going to make clustered summaries of separate variables. Clustered summaries of separate variables. Category is going to be our male and female sex. And then the femur, and then we're going to use the z-scores to look at the graphs. And we'll explain this when we look at it. If you look at this category, number 12, you see that they're above the mean on femur, above the mean on foot, above the mean on arm, and above the mean on head. But, I'm sorry, head, they're at the mean. This one, almost said it, below the mean on femur, below the mean on foot, below the mean on arm, below the mean on height, but above the mean, or right at the mean on head size. So that should give you a clue about which group this is, what number 12 represents, and what number 66 represents based on the data that we've looked at already this semester. Whew. So now, let's go back up and look at our graphs again. Arms look a little weird, so we might want to look at arms. Definitely start looking at feet. Okay? So when you start looking at feet, it's really important to remember that I was going to play the Boo Creepy Foot Doctor scene for you, but I guess I won't. It's very important to remember that we have to try to identify parameters. So let's go back and look at the data. Okay, and look at the data and look at z-scores. If there is a parameter of feet, we're going to sort ascending. We're going to notice a pattern. And just by sorting ascending by foot, 1, 2, 3, 4, 5, is it normal to find 5 people, 6 people that are outside 95%? Probably not. Especially when you notice that it goes from all the way from -1 to -2.5. Then it goes right to -0.25. If we look for people with like kind of clown feet, there's a few people that are close to 1. Oh, there's that fly. Hello, land right in my eyeball, fly. You can see it on the camera. It's awesome. There's a few people that are above the mean, but these people are really below the mean. And if they're below the mean, I can then just say, wow, let me see what I can, if I code these people differently. I'm going to code these as 1. Okay? I just coded them as 1 because there seems to be a little different. That group right there seems to be a little bit different. So if I make my error bar graphs again, same error bar graph, but now I'm going to code for, have that third group in there. Let's see what happens. Here's my 1s, which are normal length femurs, very small feet, very small arms, short, with normal sized heads. Okay, so then maybe this identifies a different parameter by sorting at their feet.